Okay, now we are going to start our next question. This question is relevant with, I think, risk and uncertainty. Keystone is a recently established business specializing in the manufacture of a range of products for the fitness and health food market. It has recently developed a new product, Protein Power, which it is almost ready to launch. Keytone Company estimates that demand will be between 3,000 and 4,000 units per month. But protein power can only be manufactured in batches of 500 units. Therefore, Keytone Company must decide whether to manufacture 3,000, 3,500, 4,000 units. Given the short shelf life of the protein power, any units remaining unsold at the end of each month must be thrown away and have no scrap value. Variable production cost of making one unit of protein power is 6.2, 2.7, 1.35. Protein power will be processed on machine X every time the machine is set up for a new batch of 500 units. It must be cleaned and inspected at a total cost of $240. In addition to the above production cost, Keytone incurs selling and distribution cost of zero point 0.9 for every unit sold. Keytone Company has launched only one other similar product and based on the information from that launch, has estimated that the probabilities associated with each demand level of protein power are as follows. Probability point 2 demand is 3,000 units. Probability point 3 demand is 35. Probability point 5 demand is 4,000. However, while Keytone Company believed that it could achieve a selling price of $35 per unit for protein bar to sell up to 3,500 units, it would need to charge a lower selling price of $33 per unit for all the units sold to achieve a sales volume above this. There are two options. One is to charge 35 or 33. The managing director is very risk averse. So the risk averse always goes for what? He always goes for maximum, trying to maximize the minimum possible, and is concerned that probabilities noted above may not be accurate. Yes, it is always a risk that we are using probability analysis which will be or which could be inaccurate. They have been in discussion with a local market research company who has offered to provide for a fee of 100% accurate information about the actual demand level for protein power. Construct a payoff table to show all the possible profit outcomes and recommend the level of production ketone companies should choose based on expected values. Calculate the maximum fees which Keytone would be prepared to pay the market research company for the information about actual demand levels. Briefly discuss whether it is appropriate for the managing director to use expected values as a basis for making the decision about the production level of protein power, and explain one alternative decision criterion which might be more useful. First of all, we need to what? We need to construct payoff tables. Now we are constructing or we are expected to construct payoff tables. Demand is what? Demand is he's saying that maximum is 3,000. 3,000 and make and sell 3,000 maximum which can be sold. Then he is saying it could be 3,500, but sales will be 3,000. It could be 4,000 production, but sales will be 3,000. So these are the scenarios. If we look at the first one, we have to do what? We have to may do number of workings. And what are these workings? For example, we have to calculate sales. First of all, net sales proceeds. Sales proceeds. Suppose 3500 units. Selling price is what? 35 up to 3500. And variable cost is what? Selling and distribution. It is 0.9. Selling and distribution cost is this one. So 35 minus 0.9, 34.1 is the NRV, what we can say. If we sell greater than 3500, greater than 3500, then selling price will be 33. It will remain the same 0.9 and 32.10. So what could be the total revenue? There are three options: 3000 for 3500 and 4000. So with the 3000 we can earn maximum 34.1 as an NRV into 3000. 34.1 into 3000, we can earn 102300 dollar. The other level is 3500. Again for 3500 maximum we can earn as an NRV. It is 119350. Third one is 4000, 32.10 into 4000. It is 128,400. So this could be your maximum revenue. Now to earn this revenue, we have to pay what? We have to pay this variable cost. So we will calculate variable cost or total variable cost for 3000 multiplied by sum of these variable costs, 6.2 plus 2.7 plus 1.35. So 10.25 is the total variable cost per unit. 3500 into 10.25, 4000 into 10.25. 30,750, 10.25 into 3,500, 35,875, 4,000 into 10.25, 41,000. This is the variable cost in the three different situations. Then we have what? We have, I think we have what? Is there any fixed cost? Demand will be in between this, and setup cost is also needed. Each batch will consume a setup cost of 240. So now we will calculate setup cost. If 3000 divided by 500, 6 setups into 240, 6 into 240, 1440, 3500 divided by 500, 7 into 240, 1680, 4000 by 500, 8 into 240, 19. So these are basically the costs, revenue, and setup cost, which we determine we have to enter all three different levels of expected sales. Now we will do what? We will say, we will calculate, even if we have a demand of 3000, we are making 3000. We have demand of like 3,000, we are making 3,500. We have demand of what, 4,000, 3,000, we are producing 4,000. Now we will calculate basically net profit in each option. First one is with the 3,000, sales revenue is 102,300. This sales revenue is basically NRV because we have already deducted this selling and distribution cost minus variable 30,750 minus a step up fixed cost. I think it was 1450, 1440. So 102,300 minus 30,750 minus 1440. We have what? We have 70,110. If we have the same demand of 3,000, revenue will remain same 102,300. But if we are producing 3,500 units, cost of variable cost will be 35,875, 35,875, and we have another 1680, I think, as a setup cost. 7 into 240 were 1680. So 102,300 minus 35,875 minus 1680. 102 300 minus 35 875 minus 1680. Answer is what? Answer is 64,745. Next one is net profit 102 300 minus 41,000 minus 1920 59,380. Sorry, revenue in this state. The other option is company is making and selling 3,500. Sorry, we are done with the two options. If making and selling 3,500, then net profit is revenue 119,350 minus variable cost is 35875. I think for 3,500 we have 7 batches, so cost will remain the same. Setup cost 1680. Now we can solve 119350 minus 35,875 minus 1680. So answer is 81,795. If we are producing and selling 3,500 units. If we are producing 4,000 and selling 3,000, what would happen? Net profit 102 300. We have to pay the variable cost of 400 units, which is 41,000. And we have to pay setup cost of 8 batches, which is 1920. So 102 300 minus 41,000 minus 1920, 59,380. So if we make 4,000 and sell 3,500, revenue will remain the same 119350, but variable cost will be 41,000 and setup cost will be 1920. 119350 minus 41,000 minus 1920, 76,430. Now the next scenario is if we make and sell 4,000, next net profit we are making and selling 4,000. So 128 400 minus 41,000. This time there is no closing stock. Minus 1920. 128 400 minus 41,000 minus 1920. We have 85,480 as profit. The other option is what? So these were the options which we used and we determined these values. Now we need to do what? We need to show these values in the table with respect to our probability. Like part A is basically requiring a payoff table where we have demand in one column. Now I would like to use the Excel. If we make column here, demand, next one is probability, third one is supply, because we are required to make the relationship. Supply is 3000, supply is 3500, supply is 4000. Demand is what? It is 3000, it is 3500, it is 4000, and demand has its probability as well, zero point 0.2, zero point 0.3, zero point 0.5. So 0.2, zero point 0.3 and 0.5. Now we need to show what after probability there are different profit values. For example, if there is demand is 3000, supply is 3000, demand is either greater than 3000 or less than 3000, you can do what? You can maximum sell 3000 because your supplier is not selling you more than this. So your maximum profit will be 70,110 in all the three situations because you are not able to sell more than this. 70,110 maximum you can earn. If supply is what? Supply is 3,500 and your demand is what? Demand is 33,000, then you can earn maximum 64,745. But if your demand and supply match with each other, then it will be 81,795. And if you are purchasing 4,000 but your demand is, sorry, if your supply is 3,500 but your demand is still is 4,000, you are unable to fulfill this demand because your supplier is not selling more than this material. So this is what 81,795 is the maximum contribution or profit which you can earn, where supply is 4,000 but your demand is 3,000. What can you earn maximum? 59,380. Where your demand is 3,500 but the supply is 4,000, you can earn 76,430. Where your demand and supply is matching with each other, you can earn what? 85,480. So requirement of the question was what? Requirement of the question was to construct payoff table to show all the possible profit outcomes and recommends the level of production Keynote company should choose based on expected values. Basically, we determined 9 expected values. Why? Because we have 3 different possible level of demands and we have 3 different possible level of supplies. We did not calculate 9 figures because at times figures are same, like 71,110 is used 3 times, then 64,745 is used by us 2 times. So you can say, and this one the third time, and then we use the 3 values. Alternatively, you can see that we calculated or 9 values. This was determined by us or used by us three times, but we calculated once. This was used by us two times, but we calculated once. So we use these two values five times, and then six, seven, eight, nine. So you can see that we use nine possible outcomes, or we calculated nine possible outcomes because there are three levels of supplies and there are three levels of demands. So nine possible outcomes or nine possible values are needed. Further, what is the requirement of the question is, after constructing payoff table, what should we do? And recommend the level of production Keytone company should choose based on expected value. So now on the basis of expected value, where we are in maximum gain. Expected value. Expected value is zero point 0.3, which is most likely the expected value. And if we calculate this expected value will be same 70,110 because it is same everywhere. But if we look at the other one where we have 64,745 multiplied by 2, oh sorry, multiplied by zero point 0.2. Then we have 81,795 multiplied by zero point 0.3. Then we have the third one, 81,795 multiplied by what? 0.5. So one thing I would correct, this 64,750 is used by us just one time. This value was used by us two times. But you can see that in total we have nine values. So where we have the maximum expected value of profit, you can see the values where you have maximum value. It shows that at the level of 3500 we have maximum expected value of profit, because in this situation we have profit at the second level if demand is 3000 but we are producing 3500, and at next two levels our profit is higher with is 81,795, or in comparison with the supply of 4000, two times higher our profit is higher. So in total we can say that our profit is greater in comparison with the supply of the 3000, and as well as in comparison with the supply of the 4000. Anyone, any question? No question? Okay. Now we will look at the B part. What is the requirement of the B part? Calculate the maximum fees which Keytone company would be prepared to pay the market research company for the information about actual demand levels. Okay. Basically, he is saying that what information cost you can afford with these probabilities. We are saying that our expected value At 3500 level will be maximum what? First we have to calculate this value. Expected value here. Expected value at 3500 is equal to 64745 into 0.2 plus 81,795 into 0.3 plus 81,795 into 0.5. So it is 78,385. If we want to see this one, 59,385 or 380 into 0.2 plus 76,430 into 0.3 plus 85,480 into zero point 0.5. So it is higher, and the third one will remain same, 70,110, even if we apply the percentages. So this one is what? This one is the highest value, 78,385. Now we will calculate B part. This was our part A. B part is expected value of profit after perfect information. This is called perfect information of profit after perfect information. Like first one is 70,110, which is common, into 0.2. Next one is this 78,385 is the expected value before the perfect information. Then what could be the profit after perfect information? Do we have any values where we can say that this is the profit after perfect information? If we assume that 81,795 itself is the value because it is the highest possible with the perfect information into 0.3. Third one is what? Third one is again the highest with the 4,085,480. We have the perfect information into 0.5. Now what will we do? We will sum up all these expected values with the perfect information, because here we can earn maximum profit if we are working with the perfect information. But to achieve this information, definitely we have to pay cost for it. And what is the cost? If any cost is provided in the question, no cost is provided, then what we can pay at maximum information cost could be what we can earn, 81,300 maximum, minus what? Minus maximum without perfect information. So $2,915 is the cost which we can pay to get the information, maximum cost. So this was part B. Any questions? Next part is briefly discuss whether it is appropriate for MD to use expected values as a basis for making the decision about the production level of protein power. And whenever you have and in your question, it means it is the second part and you are expected to write separate answer on it. Explain one alternative decision criteria which might be more useful. So briefly discuss whether it is appropriate for MD to use expected values as a basis for making the decision. Yes, it is an acceptable level. We can use this uh, expected value method for the decision making purposes because it is providing us different possible outcomes, and it helps us to determine any average value, or it can help us to determine most likely value which can arise maybe uh, actually during the performance of the business. But again, it is not necessary that these expected values or possible outcomes will work actually in the same manner, and it will be useful always. Maybe actual results will be completely different than the expected values because expected values are just subjective numbers. So we cannot rely unnecessarily on these probabilities or possible outcomes. We can use these just to determine the average, or we can use just to determine either it will be useful for us or not, and it can help us to determine some value of profitability or not. And explain one alternative decision criterion which might be useful. There could be an alternative which is like maximax, maximum, and minimax regret, which is alternative which can help us to provide uh, maximum profit, maximum possible profit, and minimum possible profit, and how to avoid our losses. Just like in the given scenario where we did 9 working, we can say that if we have perfect information and everything goes well, this is the maximum profit. This is called maximax. So this is called what? This is called maximax, maximum possible profit. Next one is what? Which maximum is what? Maximizing the minimum possible. So how to calculate the minimum possible profit? 70,110 is the minimum possible profit. So this is the way to determine, or which we can use for our decision making purposes. So this was the whole question ketone, which you can attempt again after reading this, after listening this recording. And if you have any queries, you can ask me.